In addition to direct substitution, remember guys, you got to think, this is a special case of piecewise functions. Everybody look up there. This is a really special case of piecewise functions. All this piecewise function is saying is you're going to graph f of x for x squared plus 1 for all values of x except for when x equals 0. So the piecewise function is basically that graph except when x equals 0. And then for that one given value where x is equal to 0, it's just equal to 3. But it's only equal to 3 when x equals 0. So that is just a dot. That's it. So what does x squared plus 1 look like? Well, it looks like this, right? Correct? And then we know that at x equals 0, though, this cannot equal 0. So there's a hole there. But at x equals 0, it's equal to 3. OK? Now, again, I asked you a couple questions. First, I asked you, what is the limit? So now that we graphically can see this, where are we approaching from the left and from the right? What y value, what height are we approaching? 1. Very good. Right? And then I ask you, hey, is this a discontinuity? And if it is, describe it. Well, now we can see that this is just a hole, not continuous. Right? It's not continuous. There's a hole. The hole there. So look at these types of piecewise functions, because you're going to see these quite a bit. And so it's helpful to know that, oh, this is going to be, that's where a hole occurs. Right? And that's helpful. Yes?
So even though you have like the 1.3 not touching the line, that wouldn't be considered a jump?
No, because the function is literally just evaluated at that point. Because like the same thing, just a little sidebar. What if I said f of 0? Well, when x equals 0, f is equal to 3, which is that point. OK? Now, on the next one, though, that one is a little bit different.